as you can see the animation of here, cam is nothing but wherein a particular element is performing the reciprocating motion due to the rotary motion of other elements. So basically it is converting the rotary into reciprocatory, and in some cases it need not be strictly reciprocatory also, it will be oscillatory motion also. Okay, so so you can see the definition here. It converts the rotary, oscillating or linear motion into a linear or reciprocating action. So it can be rotary to reciprocating or rotary to linear motion and vice versa, of course, to carry out some useful work. Okay, next we'll have to understand which are the different types of cams that we'll be going through in this unit. So the first one is called as the plate cam. We'll see the image of this later on. The second one is cylindrical cam. The third one is called as face cam, and fourth one is called as end cam. Remember this plate cam, this is also called as disc cam. Okay, and the numericals or the construction what we'll be doing is with respect to this plate cam or disc cam. Okay, so as you said, the plate cam, sometimes it is also called as the disc cam. Okay, let us see how it is working here. Yeah, this one is the example of plate cam, or it is also termed as wedge cam depending on the shape, or it is also called as the disc cam, wherein I can see over here uh, sorry, yes, we are going to call it as a plate or disc which has a specific shape which is usually not a circular shape. So for a given circular disc, okay, so we are having some additional profile like this. Okay, so this entire thing becomes the disc or the plate upon which we are having the follower over here. Okay, follower is a component which is going to convert the motion from one form to the other form. So as the plate or disc rotates, you can see that the follower is going to reciprocate in vertical direction. On the other hand, on the left side, you can see there's another cam. It's called as wedge cam. Okay, here we are having a plate of different profile over here. As you can see this, the profile is changing continuously. So as this wedge moves along its axis, you can see that the follower will either move downwards or upwards. That means it is reciprocating in the vertical direction. Okay, so this is the plate or wedge or disc cam. If you see cylindrical cam, then we for the given cylinder, a particular groove is made over here. Okay, and inside this groove we are fitting the follower here. So as this cylinder rotates, because of the groove, the follower is going to move in that groove and have the motion in the direction that I've marked. So as the cylinder rotates continuously, we can see that the follower will keep on reciprocating in the direction as shown in the figure. Okay, so this type of cam is called as cylindrical cam. Next we have phase cam. See, phase cam is the modification of the disc cam. In the disc cam, you can see that on the disc we were facing the follower, and as the disc rotated, the follower is to move up and down. But here, instead to place the follower on the disc, we are facing it inside the face. So you can see the face of the disc is having a particular slot or a groove, and inside this groove we are putting the follower. So it is a merger or mixture of the cylindrical cam as well as the plate cam. Okay, so as this face of the disc rotates, the follower will keep on reciprocating. Okay. So this is called as phase cam. This is the end cam. In the end cam again, similar to the wedge, but here if you see the wedge cam, it is planar. That means it is having a single plane and it is flat. But if you see the end cam, onto a cylinder profile is cut in such a way that it forms a particular shape. So as this cylinder, which is a cutout, as the cylinder rotates, the follower will again keep on reciprocating onto this particular shape profile. So this type of cam again is called as end cam. This is again a modification of wedge cam. Wedge is a flat one, end cam is a non-flat. It can be circular or it can be of any other shape also. It need not be a perfect cylinder. It can be of any other shape also. Now let us study what are the different types of followers here. Okay, we have understood the different types of cams. Let us understand what are the different types of followers. So the first one, or the most common one, which we are going to understand, is the knife follower. As I can see the diagram here. Okay, the one which I'm highlighting is nothing but the knife edge follower. So this is the knife edge follower, which is placed inside the guide base. Okay, and as the cam rotates, this particular follower is going to reciprocate in the vertical direction. Now, what are the advantages and disadvantages of this cam profile? The advantage is it's the most easiest way to manufacture this particular profile as compared to the others. Okay, simple knife edge, and it's most widely used because of the simplification of the production. Then comes to the disadvantage of this. Okay, can anyone tell me what could be the disadvantage of this? Okay, let me draw the cam over here. Okay, and let me draw one knife edge profile. Okay, so it is placed under this guides. So what will happen when this cam starts rotating? Okay, so because of this cam profile shape, the follower is going to lift up. Okay, say from this point to this point till here. Then again further from this point to this remaining point, it is going to come down. So for every rotation of the cam, it will rise up and then again fall down. Now suppose I want this cam profile to be used for a particular application wherein I want the follower to precisely lift, say for example 10 mm. This is my requirement. I want the follower to be lifted by exactly 10 mm. As and when you go on using this for a longer period of time, the sharp edge at the tip of this particular follower here will get worn out and it will become blunt. The moment it becomes blunt, you can notice that the maximum lift, which was earlier 10 mm, now it might get to 9.5 mm because 0.5 mm has been worn out here because of the sharp tip. Now, if the application needs the precision movements, then such type of follower cannot be used here because within no time this will not be achieved, and gradually it will go on decreasing the maximum lift and it will not serve of any purpose. So wherever high precision movement is not required, at that time you can go for knife edge follower. Now to avoid this difficulty, that is difficulty of wearing out of the tip of the follower, the next type of follower is introduced, that is the roller follower. Okay. So instead of a sharp tip, there is a roller which can rotate easily, freely about this point. Okay, so now when the cam rotates, the roller is having continuously rolling action with respect to the cam. See, dragging or sliding action will result in more wear compared to the rolling action. So because of which the roller follower will not wear out as quickly as the knife edge follower, and the lift which is designed, so that lift can be retained for a long period of time. Similarly, we are having flat end followers. Again, this flat end follower is also designed in such a way to reduce the wear, because you can see this flat edge over here. Let me change this just a minute. Okay, this particular edge of the follower, and let me draw the cam over here. Okay, just a rough diagram of cam at one. So when the cam rotates, at some instant, this point of the follower is in contact. At next instance, this point of the follower is in contact. Similarly, at next instance, this point of the follower is in contact. That means at every instance, the point of contact between the follower and the cam is continuously changing. Since the point of contact is continuously changing, once again we can say that the reduction in wear is reduced here. Okay, now again the question comes, if this follower which I'm showing you right now, if this also reduces the wear, and if the roller follower also is going to reduce the wear, then what is the uniqueness of having roller follower over the flat face follower? So that you will come to know in the next slide. Let me show you here. So just to summarize here, this type of cam can be classified into three categories. The first one is based on the shape, which we have already discussed. Second one is based on the follower movement, which I'll tell you now. Third one is based on the constraint. Okay, so this we have already discussed based on the shape, whether it is a cylinder shape or flat or end type of cam and so on. Now, what about this according to the follower movement? So they say that it is dr, dr, d double rd, triple r, and drd. So here let me write it. D stands for dwell, and one of the r is rise and another r is return. Okay, so cam might be operating such that it initially goes with the dwell phase, then it rises, then again dwell, then again it will return. In the second type of category, it has a dwell phase, it rises, returns, and again dwell phase. Third one, there is no dwell phase at all, so it is rise, return, rise. And last one is dwell, rise, dwell. Okay. So just let me show you an example of this. This is the cam profile, and I have the follower over here. Okay. Let us assume that it is going to rotate in anti-clockwise direction. Let me mark the profile of the cam wherein the follower is going to move up. So let me mark it from this period. So from this point, say up to this point, what we can see here, I'll just join it from the center. So what is happening with respect to the center? The radius is continuously increasing. See here, the radius is something else, then the radius is again increased, then the radius is further increased, and the radius is again further increasing. So as the radius goes on increasing, the follower is going to move up. So I've got the first stroke, say as rise. Then again, let me change the ink color. Okay. A small portion, say from this point to this point, is such that there is no change in the radius. That means this radius and this radius is same. So So if there is no change in radius, then there won't be any movement of the follower. That means it will undergo dwell period. This is called as dwell. Dwell is something wherein there is no motion of the follower or there is no variation in the radius. Again, starting from this point, you can see up to this point. What is happening here? The radius is constantly reducing. The radius is going on becoming small. So as the radius goes on becoming small, then what will happen? The follower will start coming down. So this I'm going to call it as return phase. Again, starting from this point up till here, there is no change in the radius. It is a constant radius. Since the radius is constant, there won't be any motion of the follower. So it is again dual period. So this type of cam profile, what I've drawn, is known as RDRD or DRD. You can start with R or you can start with D. So it can be called as RD or it can be called as DR. On the other end, if I draw a cam profile, something like this. So you can see that starting from this point, okay, the radius is continuously increasing up till here. So this falls with rise to. Again, starting from this point, you can see that the radius is continuously decreasing. So it is a return. Again, you can see that there is a radius with continuous increase. So again, it is rise. Then further again return. So this type of cam, wherein you don't find any profile with the constant radius, this is called as rise, return, rise, triple R type of cam. So depending upon the shape, we can have the dwell in between rise and return, or we can have rise and return in between the dwells, and we can have the cam profile without any dwell, that is rise, return, rise. Okay. In the next category, we'll be studying this types of followers here. So again, according to the nature of surface contact between the follower and the cam, we have described this, which we have already gone through it. Next, we'll see what is according to the type of motion of the follower. So I have first one translatory, second one is oscillatory. So let me draw that and show you. Suppose we are having a cam and I'll draw the knife edge over here. Okay. We are having the guide ways for the knife edge, due to which what happens when the cam rotates, the knife is going to have, or the knife edge is going to have the vertical reciprocatory motion. Okay. I'll take up the same cam and instead of knife edge, let me draw a roller. Okay, so this is the roller follower. Once again, it has the guideways. So as the cam rotates, you can see that the roller follower is going to have the vertical reciprocatory motion. Now for this roller, I have an option that for this cam, the placement of the roller, I'll change it. Instead of making vertical, I'll make it horizontal. Such that it is pinned at one particular point. Now what will happen when the follower starts rotating? It will reach over here. It will rise. Then again for the further rotation of the cam, it will again fall down. So what is happening now? It's not reciprocating. The follower is oscillating about this particular point O, say with an angle of theta. Theta is the maximum angle with which the follower can oscillate. Oscillation is always given in terms of the angle. Okay, so the roller follower, I can make it with reciprocating also arrangement, as well as I can make it with the oscillatory also. Whereas flat faced follower, I have to ensure that the flat faced follower is having only vertical displacement. You cannot rotate this flat face follower so that it can have the oscillatory. That's why I told you there is a difference between the roller and the flat faced in terms of the functionality. The basic purpose is to reduce the wear friction, but here having the roller gives us an edge of having the oscillatory motion also. Is it clear?
Yes, sir.
Let me know if you have any doubts till this step.
No, sir, no doubts.
No doubt, sir. Clear.
I guess this should be like a revision for you guys, which you already done. So there is one more type, one more category of description which I need to tell. The last one. Suppose we are having a cam, and this is the follower here. Okay, so it's a simple knife edge follower, but what we can see is the axis of the cam, which is this, I'm marking here, and the axis of the follower, they are in line or they are collinear. Okay, so such a cam follower system is called as inline cam system, wherein the axis of the disk or the cam and the axis of the follower are inline. The same thing, we can also mount the follower over here. Okay, now you can see the axis of the cam is here and the axis of the follower is over here. Okay, so there is some distance gap between the both of these axes. So such an arrangement, we call it as offset, or in some textbooks it is also called as eccentric cam system. Okay, now what are the different types of numericals that we'll be solving? It all goes with the combination. Of course, in the type of cam, we'll be dealing with only the cylinder disk cam or the plate cam, so that is for sure. But when it comes to the follower, so we can have knife edge, we can have roller, or we can have flat. Okay, with respect to the motion of the follower, we can have either inline or we can have either offset. With respect to the type of type of followers, or with respect to again motion of the follower, we can have reciprocating or it can oscillate. Okay, and lastly, with respect to the nature of the motion of the follower, it can move with uniform velocity, it can move with something called a simple harmonic motion, it can move with uniform acceleration, or it could move with the cycloidal nature. So these are the different combinations with which we can generate the problem. So I can give a knife edge follower which is inline, which is reciprocating, and which has simple harmonic motion. Or we can give you knife edge problem which is having offset, which reciprocates, and which has uniform velocity. Okay, we can give roller follower which is inline but which oscillates, and it has uniform acceleration. So there can be n number of problems with various combinations. Okay. Of course, that doesn't make any sense to solve n number of problems. We can solve fewer problems by taking the all possible combinations. So that means if I take knife edge, then I'll solve one problem with inline, reciprocate, and with the SHM or UV. Then I can take a roller follower and I can give you offset, and I can also make it oscillate, and I can cover the cycloidal and uniform acceleration. So like this, if we take 3 to 4 different examples, then all these possible combinations will be covered. So we'll be taking up the problem in the next class now. I would like to know, do you want me to just demonstrate how the construction is to be done, or you want to do it along with me? Because
Sir,
I'll plan my class accordingly then.
So we'll do together. We'll
Okay,
also.
done. Uh, okay, then we'll meet tomorrow and we'll start with the construction of the cam profile. Okay, if you have any doubts, please let me know, or else we can wind up the class.
no doubt, sir.
Okay, thank you.
Oh, thank you, sir.
Thank you, sir.